Hello everyone, for this video we're going to talk about solving problems involving arcs and chords. Now for our learning target for this video, I can solve problems involving chords and arcs. So let us have our first example. So for our first problem, if the radius of a circle is 25 centimeters, what is the length of a chord whose distance from the center is 7 centimeters? Of course, we need to have our illustration so that we can easily interpret or solve the given problem. So we should have our representation for each given data. So we have our radius, our chord, and of course, let's represent the distance of the given chord from the center of the circle. Now, I'm gonna put the details here in our illustration so that we can easily find out what would be the possible way or method are we supposed to use. So here for our radius, it's mentioned it's 25 centimeters. And for our distance of the chord from the center of the circle, we do have 7 centimeters. And now, so we are asked to find out the measure or the length of the entire chord. As you can see, we do have the line segment X, and let's say I'm gonna name it as point A. Okay, so we have the line segment XA. So of course, to represent the distance of the chord from the center of the circle, we are going to draw this line segment perpendicular to the chord. And here is it. And now, since it's perpendicular, of course, we are expecting that it would bisect the chord into two equal segments. And now, to solve this problem, let us have this process first. As you can see, we do have the triangle YXA. We do have the given data for the two sides of the given triangle, which is 25 and 7. And actually, let us find out first the measure of this side. And if we're going to find out the measure of this side, after that, we are just simply going to multiply it to 2 so that we can get the measure of the entire chord. But of course, for now, let's just focus with finding the measure of the half of the chord first. So let us have what formula are we gonna use. So here, based on the given data, since we do have the measures of the two sides of the triangle, let's make use of the Pythagorean theorem. So we are more particular with c squared equals a squared plus b squared. But let's be more specific, writing the corresponding segments for each letters in our given formula. So we all know for c, that refers to our hypotenuse, which is here in our illustration, that refers to the measure of yx or line segment yx. And how about for a? So it measures, it refers to the measure of our line segment xa. And for our B, that is what we're looking for, and that is measure of YA. Okay, so now substituting the measures for each given side. So we have for YX, which is 25 centimeters, or I'm gonna put the 25 first. Maybe I'll just put the unit of measurement in our final answer. And for XA, we do have 7. And of course, for YA, we will just simply copy it for a while. Okay, now 25 squared, we all know that that is 625. And 7 squared, that is 49. And of course, you just simply copy the YA squared. Okay, now we need to combine like terms. So simplify. I'm gonna use the shortcut by means of transposition. So we will have this. So 625 minus 49, it's 576. Okay, and that is for measure of YA squared. So this is not yet simplified, so we need to get square root of both sides of the given equation. So that means we would have square root of YA squared and square root of 576. Thus, we would have YA is equal to 24. Okay, 24, but this is not yet our final answer. This only means that the measure of this half of the chord is 24 centimeters. And of course, based on our illustration and applying theorem 105, so since we do have this line segment from the center of the circle which is perpendicular to our chord, it would bisect the given chord into two equal segments, and that means if YA is 24, therefore AZ is 24 centimeters as well. And that our final answer for this problem would be, so the distance of the chord from the center is 7 centimeters, and then the radius is 25 centimeters, and how long is our chord, and that is 48 centimeters. Okay, so we are done with this problem. Next problem, we do have diameter of the circle is 80 centimeters. If the chord is 8 centimeters away from the center, how long is the chord? Now let us have our illustration again. So representation for diameter, for chord, and of course for the distance of the chord from the center of the circle. And let us put labels so that we can easily identify or name the given segments that we are going to use for our process. Okay, but let me name this first, this one, so that we can be more specific. So we have here, so let's plot first the given data. So it is mentioned that the diameter is 80 centimeters, but here we're going to use the detail for radius only. So let us get half of 80, and that is 40 centimeters. And how about the measure of line segment AX, or the distance of the chord from the center? It's given as well, which is 8 centimeters. And now we are going to find out the measure of the entire chord. And here, as you can see, this is the same with the previous problem that we've solved. So we're going to find out the measure first of line segment CX. And we all know, since the line segment AX is perpendicular to the given chord, therefore it bisects the given chord, and thus CX is the same with XD. Okay, so but for now, let us focus with finding the measure of line segment CX. Okay, so we are going to use the formula again for Pythagorean theorem. C squared equals A squared plus B squared. And to be more specific, let us write corresponding segments for each letters of our formula. So for our C, or the hypotenuse, is CA. And for our A is AX. And for our B, we do have CX. Okay, now, so let us substitute the given details for our CA. So we have 40 squared, and for our AX, we would have 8, and then squared, and then plus CX squared. Okay, now, so let us get what is square of 40. So that is 1600, and square of 8, which is 64. Then just simply copy the CX for a while, then combine like term, guys. So we have 1600 minus 64. I'm just going to use the shortcut here. So we have 1600 minus 64, it's 1536. Okay, now this is not yet the final answer, because as you can see, we do have squared yet here for CX. So therefore, we need to get the square root of both sides of our equation to simplify it further. Okay, so get the square root. So square root of CX squared is CX. And 1530 is not a perfect square number, so we need to factor this out. Okay, and make sure that one of those factors are perfect square so that we can simplify it easily. So here, I'm gonna use 256 times 6. Okay, now I know that square root of 256 is 16. Okay, and since 6 is not a perfect square number, it will remain inside the radical sign, and thus cx equals 16 square root of 6. So this would be our equivalent for, or the measure of our line segment cx. So for this is 16 square root of 6. But of course, since we are supposed to find out the measure of the entire chord, therefore our final answer would be, let's just double it. So 16 square root of 6 plus 16 square root of 6. So we would have 32 square root of 6. So that means this would be our final answer, but I'm missing something. What? The unit of measurement. So centimeters. And we're done. Okay, for our last problem exercise for this, if a chord of a circle is 24 centimeters in length and 9 centimeters from the center of the circle, find the length of the radius. So we are supposed to have our illustration again so that we can easily interpret and analyze the given problem. So here, so if a chord of a circle is 24 centimeters in length, so let us label it first. So 24 centimeters in length. So therefore, we have here a segment perpendicular to our given chord. I must name it first so that it would be easier for us. So let's say it's letter A again. Okay, so we have OA. This is perpendicular to our given segment, thus it bisects the given chord JY. So thus, that means JA is equal to 12. Okay, 12 centimeters. 12 centimeters. 12 centimeters. Okay, we didn't change anything there. So all in all, the entire chord is 24. And our distance of the given chord from the center of the circle is considered 9. Okay, so I'm gonna put here 9 centimeters. And what we're looking for in this problem is this one, the radius. Okay, which is considered our hypotenuse, right? So because it's the opposite side to 90-degree angle. Now, what formula are we going to use? Of course, the same Pythagorean theorem. So c squared equals a squared plus b squared. So here, I'm gonna put again the corresponding segments for each letter. So we have for C, this is JO. Okay, so JO and then squared. And for our A, we do have OA. Okay, and for our B, we do have JA. Okay. Now, so let's substitute the given measures for this formula. So JO, this is what we're looking for, so we don't have detail to be substituted here. But for OA, we do have 9 centimeters. Okay, so 9. And for our JA, we do have 12. Okay, 12 squared. Okay, now what is, of course, we need to simplify this. So 9 squared, we do have 81. And 12 squared, that is 144. And of course, we need to combine like terms. So we have 81 plus 144. What's the sum? It's 225. And as you can see, we do have JO squared. So that means this is not yet the final answer. Let us just get the square root of both sides of the equation. So square root of JO squared, that is JO. And square root of 225, that is what? Square root of 225, that is 15. Okay, and that means that this would be the last part of our computation, and let us not forget the unit of measurement, so centimeters. Therefore, our final answer for this problem is this one. The radius of the circle is considered 15 centimeters based on the given data. Okay, so we're done with this video. Hopefully you learned about some problems involving arcs and chords, and hopefully you understand the explanation or discussion in this video. So thank you so much for watching, and see you on our next video lesson.